We're here for another Tech Talk with Paul and Al, and he's working on a Fisher antique tube type amplifier.
Vintage, it's not antique.
Okay, vintage.
Yes, classic tube audio.
Look at those tubes, Paul.
This is from Fisher's golden era in the 60s. Tube type power amp, nearly 100 watts a channel, beautifully constructed, hand wired.
Look at the metal.
Look at the size of the transformers. Iron means bass. Iron means linearity. Iron means everything. This has iron.
And very expensive tubes.
The tubes are very expensive because they've not been made in years. But this one was brought to me by somebody who's trying to resurrect it, who'll probably end up reselling it. And I have checked it out. And of course, first thing I did was take the bottom cover off and look to see if it had been rebuilt. And somebody's done a fairly decent job, and they've used the expensive epoxy capacitors. This was nice. Few places their soldering wasn't the best, but I cleaned that up. They got a little careless right there. I'll clean that up. Strange circuit on this, which we won't go into tonight, but the initial test was to test the tubes. One tube checks a little weak, but there are adjustments to compensate for that. So I plugged it into my amp meter and watched the running amperage on it, which should have jumped right up.
Is there an off-on switch?
No, it's coming up. It's coming up. I've got it on the type 1 range. There we go. That has to warm up a little bit. Yeah, it'll come on up. Anyway, running amperage was fair. And I'm watching the tubes. Nothing crazy is going on, but I notice, well, I've got right here a filament. That's the second time that's happened. That's going to have to be dealt with. Bad socket. That these tubes are getting hot and these two tubes are not. So there's a difference in how much current the tubes are pulling. So I thought, okay, I will tip it over. And I know where the cathode resistors are. And they're right here. 50 ohm resistor to ground off the cathode of this channel and that channel. And there's small capacitors across the resistors to ground, which improves the fidelity. And I hadn't checked voltages yet. I thought, well, I'll check the resistors, make sure they're good. The cool channel, the resistor is good. Measures 50 ohms in the circuit, as it should. The bad channel that's getting hot, I'm getting 5 ohms to ground, which is bad. Resistors don't tend to go up in value, but capacitors can short. So this capacitor has shorted because this resistor is open. I now have to go find a 50 ohm 5 watt resistor and another capacitor and replace it and see what happens to see if I've got a bias issue or a bad socket, something causing that channel to pull excessive current, enough current to blow that resistor. This resistor has been changed, so this obviously is not the first time this has happened. But at least it's been well cared for. Somebody did a nice job recapping it. So it's going to be a work in progress, but that was my first stop on the diagnosis, is finding this capacitor shorted and that resistor open. But the first thing you notice if you work with tubes is you pay attention to how hot they get. And if they're cold, they're not doing anything. And if they're getting hot real fast, they're working too hard. So just feeling the heat, I knew something was wrong. Even before I hooked speakers to it or a tone generator, I knew something was up. Now eventually, of course, you'll get speakers and listen to it, or you'll get the dummy load resistors out and hook these in place of the speakers, hook an oscilloscope across here and look at the signal, and you will see things that your ears can't identify. But that's way down the road doing dummy load testing. First, you got to get the idle currents right, make sure all the voltages are correct, and then take it to the next level.
Can we see the front of it? Oh, before you do that, with that red thing right down there, is that a selenium?
Oh, this is, they rebuilt this thing so beautifully. Epoxy capacitors, pretty nice job. But they didn't change this little selenium rectifier, which provides the minus 25 volt bias which regulates the current on the output tubes. If this little bugger fails, the tubes can turn into orange glowing piles of glass, because without bias, the tubes overheat. They did everything except change that stinking little metal rectifier. This is early solid state. This predates transistors. Should be replaced with a silicon diode, and the value of this resistor has to be increased because silicon diodes don't have as much resistance as these little buggers did. So this should have been changed.
And those get hot when they run too.
Well, they smell funny because this provides no current. I mean, it's minus 25 volts at maybe half a mil. There's no current involved. What's funny on this, I got to looking at the schematic, is there's a capacitor from the winding on the power transformer, which is 25, 30 volts AC, and it goes to the balance adjust switch, and it says off A and B, and this is used to do the bias and AC balance adjusting on this amplifier. And there's pots right there you adjust. And it's funny to me that Fisher did not put test points in this to measure current on the tubes. Doesn't have them. But if you read the book, what they do is they take this 60 cycle off the power transformer via a capacitor, and they send it to both grids of the output tube simultaneously. Of course, that signal is in phase, and the grids are out of phase. So as you adjust the balance pot, you find the spot where the tubes cancel each other. In other words, minimize the hum heard on the speaker of that channel. That indicates you have achieved the balance point for that channel. So it's brilliant. And there's one bias pot for both channels, which annoys me. And there's a bias balance, which you can use to offset, like this tube that's weak, it's got an X on the top of it. I could move the bias back and forth to put a little more current on this tube and a little less on this tube and make it look like a balanced pair and get a cleaner waveform on the scope.
Okay, now let's say the simple stuff. What class amplifier is this?
It's class B.
Okay.
Yeah. It does have a cathode resistor, which most class Bs do not. They're cathode straight to ground. But this one has a damping factor feedback circuit. So there's a cathode resistor and capacitor. And there's another funny thing on this. This has a double triode preamp acting, they're in parallel. And they really should have used a bigger tube. But they've got a triode driving a DC coupled phase inverter.
Right, now what this is 50s?
This is stereo, so it has to be the early to mid 60s.
Okay.
So it's got a funny looking phase inverter circuit, and you have to look at the schematic close to realize that it's technically a grounded grid amplifier feeding the second tube, which gives you an effective 180 degree inversion of the signal.
Which the transformer's correct on the output.
Which they put it back together.
Yeah.
But usually you just use an extra tube to get that phase inversion. This is a very, very tricky circuit, and in this particular circuit, the value of the resistors is critical. You can't tolerate any variation there because it's a DC coupled amplifier. So this is one place where you really go in with a good voltmeter and make sure all your resistors are right on the money, because if they're not, you'll have distortion. So very sophisticated design, I thought.
But when it's perfect, it sounds great.
When it's right, these amps are breathtaking. Yes, yes. This is a little rough on around the edges, but working, it will be a thing of beauty. So I get a resistor and a capacitor in here, and we'll fire it up. And
now, what's the value of something like this?
These days, this amp $1,000 to $3,000 to the right buyer.
Yeah.
Of course, you'll spend $100 a pop for the tubes if you need one. But if you're an audio purist and you love the tube sound, it's worth it. And the kind of bass you get with transformers this big, the damping factor of a transformer this big really brings out the best in low frequencies.
Yeah.
And the clarity of the treble can be amazing.
And the other thing about this is this would work with like a clips horn.
This is what you would want with a clips or any of the front-loaded horn theater quality large format speakers.
Yeah.
Air suspension bookshelf speakers would be a waste of time.
Yeah.
This is for somebody who's going to fill a concert hall or a big house with really beautiful, rich music that you can just see into the depth.
Yeah.
Yeah.
Like a voice of the theater speaker.
Voice of the theater, yeah.
Or a clips or a...
Right. Or
Yeah.
Fisher made good speakers back then. But they probably made better amps than they did speakers.
Well, was this in the commercial use or a home use?
This was a high-end home unit.
Okay.
High-end home, yeah.
But it could have been used in a commercial use too.
Could have been, but this was high-end home audio. Yeah, this was a rich man's stereo system. And this probably cost $800 or $900 in the 60s, which was a lot of money. Good thing back then the tubes would have been cheap. But
Yeah.
anyway,
But could you duplicate this sound with the transistors?
be very difficult.
Yeah.
Very difficult.
You really never could quite get there.
No, there's things that transformers do that yeah, you can plot it mathematically and emulate it with computer algorithms, but it's just not the same.
Just not the same.
Not the same. Nope.
Because this is pure analog. It never goes through
Pure
a digital
analog.
loss situation.
Nothing.
Yeah.
No. What goes in
Because
comes out.
audio's analog, it isn't digital. And then when you go into digital, you have to sample it, which means you lose something.
Yeah, it's not right. It's not right.
Well, that's the thing of beauty.
I say, interesting circuit, and it's going to be fun to get it up and running. I'm just glad I caught this channel running hot before I spent much time with it. Now I know, go get a resistor and another capacitor, and come back tomorrow and fire it up and make sure that both channels are running cool. And then we'll take it from there and start.
There's not anyone who really knows how to work on these anymore.
Very few of us left. Yeah.
You give it to somebody 500 years from now, they wouldn't know what to do.
The guy that bought this, of course, he knows nothing except that it's valuable. And the guy he bought it from probably said, well, I had it rebuilt. It just works great. And I'm sorry, it wasn't working great. I mean, it lit up, but if I'd put a speaker to it, this channel would have been okay, except for that tube that's not lighting up. That's a bad tube socket, probably. This channel would have sounded like crap because without the cathode resistor, that controls the bias and the damping, and it's using the capacitor as its current path because the capacitor shorted, because without the resistor to dissipate the voltage, the capacitor's probably looking at 100 volts off that tube.
So it's out of its characteristic.
Yeah, the resistor's open for some reason, probably because these tubes pull too much current.
And it probably moved it closer towards saturation.
It could have. We may have a tube that's shorted. I don't know yet. But it blew the capacitor, so I had a current path. It would have made sound, but it would have sounded weird. So we're on the right track here.
Yeah.
But yeah, this is all part of the process of analyzing and tracing, and before you waste a lot of time with it, get to the root of the problem.
You gave us a lot of good tips and tricks today.
Yeah, this is a fun one. And I wasn't expecting to find an open cathode resistor. I was trying to verify that, the resistor is good, and then we'll check the voltage. And I go, wait a minute, 5 and 50, either something's wrong or my voltmeter has gone out. No, the voltmeter was right. This channel had a problem. But my fingers told me initially that, wait a minute, these are getting hot, these are not. Something's wrong. Something's wrong. So I went to the place we would check the running current, which is the easiest place is the cathode, cross the resistor to ground, compare this channel to that channel. Didn't have to do that because I found an open resistor and a shorted capacitor real quick. So I sort of jumped ahead one step. But
that's amazing.
That's why they pay me the big bucks.
Yeah. And you gave us a lot of good tips and tricks tonight.
Yeah, well, you're welcome.
So, okay, well, that's it for this one.
Yeah.
That's a miracle.
Very interesting subject.
Yeah.